We have studied the polynomial function. Now, let's discuss the power function. What is the power function? You have known the polynomial function can be expressed like this: an times x raised to n plus an minus 1 times xn minus 1 plus until plus a1 x raised to 1 plus a0 x raised to 0. Here, you know, this term can be simplified as a0 because x raised to 0 equals 1, so the last term can be expressed as a0. Now, observing this polynomial function, if for the specific situation, the polynomial function is like this: an times x raised to n. That is it. In this expression, just one term. The other terms disappear, so we say this function is a special situation for the polynomial function, but it has its own name, that is power function. Alright? Here, please observe this expression. This an is just the coefficient of this power with the exponent n. We have known all of the exponents in the polynomial function should be a whole number. A whole number means non-negative integer, alright? So this n should be a positive integer or 0. If n equals 0, this polynomial function will be an times x raised to 0. It will be an. If n equals 1, the function should be an times x raised to 1. It should be a times x. Alright? Here, this number is just the coefficient. It's just coefficient of the power. Please don't be interfered by this n. You just need to know this number is the coefficient of this power. That's enough. Okay, next, if n equals 2, this function should be an times x raised to 2. N equals 3, it will be an times x raised to 3. N equals 4, n equals 5. The corresponding expression should be like this. Alright? Okay. For these power functions, we can say this is just degree of this power. Alright? Alternatively, we can say we just take the term with the highest degree. So we can get the power function. Okay? These are degrees for the corresponding functions. Alright? For this one, you know, this is a constant. Alright? This is a constant. If n equals 1, this is the expression. Obviously, it is a linear function. For this one, it is a quadratic function. This one, it is a cubic function. This one, we can name it quadratic function. This one, quintic function. Alright? In the polynomial function, we just take the term with the highest degree term. With just the highest degree. So in the power function, we just have one term. Alright, one term. If n equals the corresponding non-negative integers, we can get the corresponding expressions for the power function. Of course, n can be any other non-negative integer. You will get the corresponding expressions for this one. This is the power function. So in the future, if you want to judge whether a function is a power function, you just need to judge its expression. Whether its expression satisfies this definition of the power function. That's enough.